We're going to spend a whole lot of time studying triangles this semester. And the main way we're going to study triangles is by using 6 trigonometric functions. Now, to understand how those functions work, we're going to start with a right triangle. So here's a right triangle. I'm going to call this angle right here theta. This is going to be the angle I care about. So if I were drawing this angle in standard form, remember the initial side is always on the positive x-axis, and then my terminal side always shoots off like that. You can imagine that I drew a right triangle by going from the terminal side perpendicular to the x-axis. So here's my right triangle. Well, this side length right here, that's along the x-axis, so let's call it x. This side length right here, that's parallel to the y-axis, so let's call it y. And if I had drawn a circle like I did on the first day of school, then you could see that this hypotenuse of the right triangle is also the radius of the circle. So let's use r. Now with that definition, we can find 6 trigonometric ratios. They are sine, cosine, tangent. These are the big 3. These are the 3 we're going to use the most. There are 3 others. They are cosecant, secant, and cotangent. Sine of our angle theta, because it's actually a function, it uses function notation like in Algebra 1, Algebra 2. Sine of theta is the side that is opposite from the angle. I'm just going to write OPP for opposite, divided by the hypotenuse. Or, using the letters up here, y over r. Cosine of the angle is the side that is next to it, and the math word for next to is adjacent. ADJACENT, I'm just going to abbreviate it as ADJ. So that would be this side right here, the leg that is next to the angle, divided by the hypotenuse. So that's x over r, adjacent side to the angle, divided by radius. And then the tangent of the angle is the opposite side to the angle over the adjacent side to the angle. Opposite over adjacent, which in this picture is y over x. Now the other 3, cosecant, secant, and cotangent, and I see I wrote those a little bit close, so I'll scoot them over a little bit just so you can see more easily in your notes. Cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. And so cosecant of our angle right here would be hypotenuse over opposite, or if you prefer, r over y. Secant of our angle is the reciprocal of cosine. So flipping over cosine gives us hypotenuse over adjacent, which is r over x in that picture right there. And cotangent is the reciprocal of tangent. So that would be the adjacent side over the opposite side, or in other words, x over y. Now, it can be hard to wrap your head around all of that, and it can be kind of hard to remember all of it. So let's put some numbers to our example. So here is an angle going that direction. Now notice that direction, because I'm going clockwise, we have a negative angle here. And I draw a right triangle onto that angle. So here is my right triangle. Right there. And looking at my graph paper, I find that this point right here is the point 4, -3. So the x is 4, and the y is -3. Now this is different from geometry. Sides can be negative in trigonometry if the negative is there to tell me direction. And here that negative is there to tell me direction. That's not 3 meaning less than 0, that's 3 meaning down 3. So I have an x, which is 4. I have a y, which is -3. And if you do the Pythagorean theorem real quick, you'll find that your radius is 5. So now, if somebody asked me for the sine of this angle, I would say that it is y over r, which is -3/5. If someone asks me for the cosine of this angle, I would say that is x over r, 4/5. If I were asked for the tangent of this angle, I would say that is y over x, so -3/4. If I were asked for the cosecant, CSC is the abbreviation for cosecant of the angle, I would just take the reciprocal of sine. So instead of -3/5, I have -5/3. If someone asked me for the secant of the angle, SEC is the abbreviation for secant, then I would just flip over cosine. The reciprocal is 5/4. And if someone asks me for the cotangent of that angle, and COT is the abbreviation there, I would just flip over tangent. The reciprocal is -4/3. And that's how you find those. Now, one thing you will have to be careful about is that very often when you do these right triangles, the sides aren't going to work out nice and neatly to whole numbers. Let's do one more here. Let's suppose I've got a triangle drawn this way. My angle is going like so. Remember, here is the initial side right there. Here is the terminal side right there. So this is a quadrant 2 angle. And I always make my right triangle by drawing to the x-axis. And so now my angle is this quadrant 2 angle, and I'm going to use this right triangle to find the sine, cosine, tangent, cosecant, secant, and cotangent of this triangle, of this angle. Same. And this point right here that I chose, that point, let's say, is the point -5/3. Okay, so that means the x is -5. Negative, not because it's less than 0, but because it's going to the left. The y is +3, positive because it's going upward. And now I need the hypotenuse. So radius squared is x squared plus y squared. Now I know that's not the way you're used to seeing the Pythagorean theorem, but take a careful look. Leg squared plus leg squared equals hypotenuse squared. There's nothing special about the letters A, B, and C. So my x is -5. So radius squared is -5 squared plus +3 squared. Radius squared is -5 squared is +25 plus 3 squared is 9. So I get radius squared is 34. And so the radius is the square root of 34. Now, square root of 34 can't really be simplified, so I'm just going to leave it like that. Square root of 34. So now, if I want the sine of this angle, I take y over radius. I have y +3 over radius square root 34. Oh, but wait a minute. Remember from Algebra 2 and geometry, I'm not allowed to leave a root on the bottom. So I got to fix that. How do I fix that? I multiply top and bottom by square root of 34. And so on the top, I have 3 times the square root of 34 is 3 roots of 34. And on the bottom, I have square root of 34 times square root of 34 is 34. And this fraction cannot be simplified any further, so there's my final answer. Now how about cosine? I would take x, which is -5, over radius, square root 34. I got the same problem as before. I have a root in the bottom. So again, I'm going to multiply top by square root 34 and multiply bottom by square root 34. And so this time I get -5 square root 34 over 34. Tangent, I need y over x, which is -3/5. And I'm done, no roots there. Cosecant, I need radius over y. So my radius is square root 34 over y is 3. And now the root is in the top, no problem there. For secant, I need radius over x. So square root 34 is my radius over x is -5. And for cotangent, I need x over y, -5/3.